So it's challenging when you're trying to present one language on a set of slides. We're trying to present two side by side. This is going to be kind of a Java to Kotlin talk. That was the main thrust of this. If you're not Java fluent, then it should still be, you should still get something out of this. But just know that next week I'm going to be giving a Cocoa Heads talk here on Thursday, where I do sort of a very similar comparison, but Swift to Kotlin. So if you're more Swift fluent, then you probably get more out of that talk. So this is the talk titled Kotlin for Fun and Profit, and we're going to be very rigid about this. We're going to talk very explicitly about the fun parts and then very explicitly about the profit parts. And I'm going to handle the fun, and Matt's going to handle the profit. I don't know what that says about us, Matt, but I'm good with it. And this is kind of the goals for the talk. So what we'd like to do is convince you that Kotlin's benefits are real. This is Kotlin versus Java, again, remember. We want you to be aware of Kotlin's drawbacks with respect to Java. We would like you to be excited to use Kotlin. And what I'd really like is for Android developers in the room to feel like they are empowered to start writing Kotlin in production. As far as I'm concerned, the benefits outweigh those drawbacks. And so it's sort of a good tooling choice for us to start thinking about making that transition as a company. So yeah, talk, not goals. So I'd like to sort of go over some of the things that I'm deliberately not trying to do with this talk. I'm not trying to appeal to the sort of widest audience here. So again, this is mostly Java to Kotlin, that kind of comparison. I'm not going to touch on every single thing which is good and or bad about Kotlin. I'm not going to do a deep dive into any one particular aspect. And this is not this is no eggplant measuring. This is not like, oh, this language is way better than this other language. There's going to be no sort of put down of Java here. This is more of an objective measure, I hope. So what is Kotlin? If you've not heard of Kotlin, it's a JVM language, which means that it runs it compiles down to JVM bytecode in the same way that Java does. Java is sort of the canonical JVM language, but there are a bunch of others, and Kotlin is one of those. It's what I would call a modern language. So it's one of these languages very much like Swift, which has tried to take a look at a lot of other very well-established languages and cherry-pick some of the best parts. And it's also gone for sort of a multi-paradigm approach where it's pulled in some of the best bits of functional programming and put those alongside the best bits of object-oriented programming. And it's kind of like a polyglot language, if you like. It's also very concise in terms of the syntax, and it's also what I would call restrained. So this is what makes it good for use on Android. A lot of other JVM languages have sort of taken the JVM and built a totally different language on top of it, and Kotlin is more like taking Java and making it better in every little way that you could. So it's a lot less kind of different than Java. That restraint is something that I think is quite important as we make this transition. And so a brief history. So Kotlin's been around since 2010. In 2015, Jake Wharton. If you don't know who Jake Wharton is, he's kind of like the rock star of Android programming. In 2015, he wrote a white paper sort of detailing for use inside Square, the company where he works, why he felt that Kotlin was the best choice for Android development moving forward. In 2016, Kotlin hit 1.0, and you started to see it become high profile, even though it didn't have official support yet. So 2016, a lot of the conference talks from high profile speakers started to use Kotlin ostensibly because it's easier to fit on a slide, but the sort of momentum was definitely there. And then 2017, this is the reason that this talk is happening now, Kotlin was, it was announced that Kotlin will be officially supported as a first-class language on Android. So whatever support you would expect for Java on Android, you can now also expect for Kotlin on Android. That doesn't really mean a whole lot other than the fact that the tooling will, that there are slightly more guarantees that the tooling will continue to support Kotlin well. But it makes a big deal if you're trying to pitch this technology to an external company. This is no longer a sort of side thing that you would like it to try out. It's official. Like it's a first-class technology for writing Android apps. You don't even really need to make a pitch to clients anymore. So what does this mean for Java? This is the party line is this, that Kotlin and Java will both continue to be supported equally for Android development. In particular, this means that the Android team is still working on improving the Java 8 support within the Android toolchain. So if you are writing apps in Java, you will see some more of the Java 8 features work their way into Android. But I'd just like to note that in 2015, Google also claimed that when Android Studio was announced, their commitment to Eclipse was going to remain unchanged, and within a year, maybe a year and a half, Eclipse's ADT had been deprecated. So I don't know that this is necessarily going to go the same way, but it might be worth thinking about this when you're deciding whether or not Kotlin is something that you're interested in working with. I've not heard of many people start working with Kotlin who then decided to go back because Java felt better. So this is going to be just very, very quick introduction to the basic syntax, and then we'll get into the fun profit breakdown. And the comparison is going to be against Java 7 because that's mostly what we're writing our Android applications in. So if I want to declare something which is, in this case, this is like a read-only variable. In Java, I would say final string first greeting, and I would assign it to the literal string. In Kotlin, I use the val keyword to indicate that something is not going to be reassigned. And I also don't have to provide a type here. One of those modern features, kind of like Swift's modern feature set, is that there's type inference. So because this is immediately assigned to a string literal, Kotlin knows this is a string already. If I want to be able to reassign something, in Java I just omit that final keyword, and then I can reassign to a new string. In Kotlin, I have to explicitly switch my val to a var, so I'm making an explicit declaration there. But then I can do the same thing. I can reassign my variable to a new value. That was going to be part of the fun, Jason, but and also the profit. But no, you're right. You're right. No. That's perfectly fine. You're right. There are some things that are going to show up in the slides that will be revisited later a little bit. But yes, no semicolons. So if that's the bane of your existence, then that's reason alone to switch. Defining a basic member function here. So the main difference is really that the type signatures are kind of reversed here. So in the Java version, I declare this function and I say, this is going to return a string and the function name is getGreeting. And it's reversed for Kotlin. I put the function name first and then the string type is at the end of the declaration. And then the same thing happens for the parameter. So in the Java version, I say final string name. And in Kotlin, it's just reversed. You say the name of this variable is name and its type is string. Again, very similar to how Swift structures this. And again, no semicolon. Hooray. It's fun, right? Kotlin for fun and profit. Yeah, exactly. And it's one letter less than func. One letter less. That's important. Think about how many times you type function. Yeah, exactly. Minutes in a year. Yeah. Your C key will last like twice as long. Well, this will. We'll get to that. We'll get to that. Okay, so this is the point of most significant deviation. So in Java 7, if you want to be able to refer to a function, there's really no good way to do that. Everything is so object-oriented in Java that this is the best option that we have. So you could make a new function object that is parameterized by its input type and its output type. But when you actually want to create this anonymously, note that I haven't sort of assigned this to a. This is not like a subclass. This is just creating a function on the fly. I declare that, and then I say, okay, I have to override the method which is associated with the function class. The method is apply. I put my logic inside that. If I want to invoke this, I would take this object and call .apply on it. It's a whole lot of work to be able to reference a function in this way. If you want to take a function as a parameter to a method, this is really ugly. If you've written callbacks in Android, this is how your on-click listeners work. You make a new on-click listener, you have to override this method. It's a lot of boilerplate. In this case, just to be able to say, I would really like a function which gives me the length of a string. That's what I'm trying to say here, and this is how Kotlin lets me say it. So I can say, this curly bracket syntax is expressing this anonymous function for me, and I say, I take an s, which is of type string, and the function is take that and map it to s.length, which is calculating the length of that string. So there's an explicit type built into the type system for this. It's a function type of type string as parameters to int as output. So this is a huge deal in terms of brevity of code, and we'll see way more examples of this. But again, this kind of syntax starting to appear in Java 8, and very similar to what you would see in something like Swift. Okay, any questions before we get started? Okay. So the first thing I thought about with this section is, what does it mean? So I know when I write Kotlin that it feels more fun than writing Java, but I didn't really know why. And this is kind of a word vomit as to why I think it might be the case. So why is one language more fun to write than another? So I think the biggest thing is that Kotlin makes it easier to be expressive, and that's in two ways. It makes it easier for me to express some of the ideas that I am trying to communicate through code, and that's really through a larger feature set. And then it's also more expressive for readers, and that's more of a syntax thing. So as we were seeing with the previous example of the functions, it's a lot easier once you are familiar with that bracing syntax to understand what the communication is in a particular instance. It's also concise. It's nice not to have to write a lot of stuff to communicate my ideas. It's also, this is part of being a restrained language in my mind. It's unsurprising. Kotlin kind of acts how you would expect in a lot of cases. If you expect there to be a standard library method, it tends to be there. There are no sort of gotchas. That's kind of inherited from Java, maybe, that property. It's quite forgiving. And then the last two are sort of more meta about the language. Kotlin is sort of is very much ascendant right now, in the same way that Swift was a couple of years ago, which means there's a lot of energy around it, a lot of people contributing, a lot of people discovering it for the first time and writing things about it, and just generally really excited about the language, which is really fun to be part of that environment. And it's also really well supported by tooling. So one thing I guess I neglected to say, if you weren't aware of this, Kotlin was built by JetBrains, the makers of IntelliJ, the platform underlying Android Studio. So the team that wrote this also builds the tooling that we use every day. So the support for it in terms of the tooling is phenomenal. And now we have promise from Android that their support will also be phenomenal. It's not sort of a dangerous territory to venture into. So now I'm going to run through some of the things that I think are fun. And the first thing is extensions. So I'm sure all of you have written this kind of class before. This is a string utility class in Java. What I want to be able to do is take a string and capitalize it. It's not super important what the actual logic would be here. But as part of making a utility class, I need a separate file. I need to make a class inside that file. I probably need to make a private empty constructor so that you can't obtain instances because this is just a utility class. And then when I want to actually capitalize a string, I have to know string util is the class. Like I have to know it exists. So that's an onboarding issue, right? If there's an app with lots of utilities in, you have to sort of learn all the utilities as you go. And so I can achieve what I want, but it's not super elegant. And it's a lot of code to do that. What extensions allow us to do is define new methods on a type that we don't otherwise have control over. So if this was a type that I controlled, I would just add that new method into the type and it would be fine. In this case, I don't own the string type. That's a Java platform type. And so on Java, I can't add a new method to that. If I subclassed it, then I wouldn't be able to pass that everywhere I would need to. Kotlin allows me to say, okay, take the string class and add a new method to it. And then when I want to use that, I just call it on my string instance. This is, I mean, phenomenal in my mind. In Java, there is no extensibility like that. Right.
Objective-C had that.
Yeah, the Objective-C had, what are they? I forgot what they're called. Categories? Yeah. So yeah, this is a huge deal in terms of the readability, and also something I think is underplayed is the discoverability. So this is now like an autocomplete on the string. Yeah.
That almost seems too powerful.
That is a great point. It is a very easy way to sort of hide dependencies if you're not careful, and that is something that I have not written enough production code with yet to really have a good feel for where that line is. But I agree, and there are a couple of good articles about specifically being careful about how you use extensions in this way. So yeah, that's a great observation. Yeah.
So I know an Objective-C category is define methods which cannot define.
The short answer is yes. You can define like a computer property that's based on other properties of the class, but I don't think you can add storage to the class. Storage, like a new field. Yeah.
Instance properties.
Yeah.
Something to keep in mind is that extensions are resolved statically. If you're familiar with that in JVM, so they don't actually modify anything related to the string class. More of them is sugar wrapper around it.
Yeah, so effectively, after compilation, these two things would look approximately the same. This Kotlin would produce, under the hood, the equivalent bytecode that a Java like utility class would provide. But you don't have to worry about that so much.
Do you need like an import? Like, is it available throughout your whole app? How does it resolve your extensions?
It's available everywhere. So you can, that's a good separate point. These can be standalone in the file. These don't have to be in separate classes. So I could have a whole file of string extensions. And I guess part of the Kotlin compiler is that it will find extensions first, generate required class, and then, so you don't have to worry about importing at all. It's just available project-wide, or with whatever visibility modifier you apply to that function definition. So yeah, super easy to define, super easy to use. This is a good example of like a utility being replaced by an extension. Something else, this is a very, very similar example, but the only change I've made is to make it a sort of more domain-specific concept. So here, rather than having like a password utility which validates the domain idea of whether or not a password is considered good, now I can build that domain knowledge into my string type, and I effectively am starting to build out like a DSL, domain-specific language, for this application. So all the same mechanisms here, just plain utility versus domain-specific logic. And I don't know about you, but this just reads a hell of a lot better. You mean if like there was already a string is valid password? No idea. I'm just not that perverse. I haven't tried it. But I see you there, Corey. I see what you're thinking. Whew. Okay. So the next thing that's really fun, and this sounds like a really boring thing to be fun, but it's really not, is the standard library. So the standard library is made good by the existence of extensions. It means that they've been able to build a really nice standard library with a lot of the stuff that you would expect to be there in Java that's not, or a lot of the stuff that exists in Java but was kind of shoehorned in as a backwards compatibility thing. So these two examples, so these are two extension functions defined in the standard library. The first one, string.substring. Both of these basically just forward the method call from the Kotlin class onto the corresponding Java class. I don't want to say too much about how Kotlin classes and Java classes are related, but just know that's a thing. So that's one method of building out the Kotlin standard library. A second method is to take what was in Java, like a shoehorn static utility method that was put in for compatibility. So in this case, the static is lowercase method on character, and turn that back into an instance method. So again, this is an extension function. I could take a character and call .is lowercase on it, rather than having to know about the character static method is lowercase. Way more discoverable, way more readable. And then the third way of sort of building out the Kotlin standard library with extensions is just to define new stuff that's useful that you don't have in Java. So I don't know how many times I've written, not is empty checks in Java. It would be really nice just to have an is not empty. It reads way better. It's more communicative. It's more compact. So this is an example of defining that. It depends on a length property that we already have for a character sequence. So it's not sort of redefining any properties, but just exposes new ways of inspecting the object that you're looking at. And then when you put all these kinds of things together, you can get some really nice standard library methods. So this is the standard library capitalized method, which was sort of one of the examples that we talked a bit about earlier. And it builds up by taking all of these little pieces of the standard library to give you one centralized, really neat, really simple method call to capitalize a string.
So those first two functions, they're type string, but there's no return statement.
Return statement is
Does that imply, or does it just know what to do?
Yes, I don't know. I can't explain for you all of the rules around this, but there are certain circumstances in which the last statement executed, if that returns a value, that will be taken as the return value. A lot of this syntax, so this falls under the category of stuff that I'm deliberately not showing. A lot of this syntax is unnecessary also. So you could remove the type, you could remove the turn type here because it will be inferred from the last executed statement. And you can actually, in some cases, just remove the curly braces and directly assign, because of the fact that you have the concept of a function type, you could assign this directly to that substring method call. There's a little bit more syntax that is absolutely necessary here, but you're right. Returning, I guess this is an example, right? This is an example where I would otherwise normally say, okay, there's a curly brace and I return this value. So there are shortcuts to be had around returning values and assigning functions to things. Yeah. Okay. It's implicit because this is an extension function. So by default, any words like length or end methods will be resolved against the current instance. So that's the difference between this being a static method where I would have to pass in my character sequence instance and do work and return a value. There's an implicit instance floating around. So if I was to invoke this on a string, it would just take the length of whatever string I was currently.
This length would be equally as valid.
It would be valid, but it's unnecessary. Yeah. You can. There's typically less need to because you control the source, but it's something you can do. No. Which is nice in that the standard library is nothing special. It's built out of the same principles that you can build your own code out of. It's just a more fleshed out version of the Java standard library and a more consistent version of the Java standard library. So yeah, these are all available for you to use wherever. Any other questions on that? Okay. So the next big thing for me that's really fun is working with collections. And this is mostly just because working with Java collections is kind of a pain. Really unfun. So, for example, let's say I have a list in Java, and I'd like to get the first element. That's not too bad. I can just get 0. If I'd like to get the last element, I don't know if there's a better way than this. I think this is the best way I know of. I have to, call list or size, and then remember that I need to subtract 1 because I'm 0 indexed. And that will give me the last element. Extension functions. Yay, I can just call first or last. Way more expressive. Don't have to worry about index manipulation. Don't have to worry about off by 1 errors. Don't have to worry about semicolons. They would, in this case, they would return an error. They would throw an exception. Sometimes there are variants of methods, so you can call, you can aggressively call it like a dot first, or you could call a first or null, which wouldn't throw an exception, but would instead return a null. I'm not going to say anything about optionals. That's all going to be profit. But yeah, you're right to think about that. There are often overloads like that, so you can choose at the time of invocation exactly how you want the case of it being missing to be handled. Again, it's just very thoughtful, very complete standard library. So I'm going to go through a bunch of these kind of examples, and you'll probably start to get bored by the end, but it's really just to draw home the same point. So this is an example of transforming a list in Java. So first of all, I make the list with a lot of syntax. Then I make a new list to put my transformed list into. And then I iterate through the original list. And at each stage, I say, okay, add a new element to my transformed list, and it's the product of the integer with itself. So this is basically squaring every element of the list. I don't know about you, but this is way too much code to do that. This is what it looks like in Kotlin. So I declare my list, and then I take my list and I call this map method on it. And the map takes a function that will be applied to every element of the list. So this is one of what I consider like the functional light features of Kotlin. A lot of these sort of mapping and a lot of the ideas we'll see in the subsequent slides are sort of born or originated in functional programming and sort of help us think about mutability slightly better. But this is a lot more compact, a lot more readable once you're used to the map operation. One thing I should say is that I'm using the keyword it here. It is like the default. It is the default name for input to this function. If you want to, you can rename it to something else. It's just not renamed here, so I can fit it on a slide. Yeah. Oh, okay.
If there's more than one parameter that can use the function, is there like an it one, it two, it three?
I don't believe so. I think at that point you have to explicitly call out which parameters are going into the function.
Correct.
It's a lambda syntax to say these are going here and then operate on it.
So yeah, you would use like a comma separated list in parentheses. There's no concept of like a tuple destructuring in Kotlin. There's not really the concept of tuple, so there's not really an easy way to. You can't like dollars. You can't take it and call like .0.
Yeah,
that's not a thing either. So yeah, but typically for readability in actual code, it's better to redefine it anyway, and this is something really simple. Okay, so here's a different operation. Maybe this is a list of payment methods, and you're trying to filter out all the ones that are expired. Filtering a list is super common. In this case, we're just running through this list and saying, okay, take the original list and filter out everything, include everything that is larger than 2. Very similar structure to how we ran through the list the first time. In Kotlin, we have a filter method which does that for us. And again, we express this by saying, okay, filter this list. Here's a method to apply to figure out whether an element should be included or not. Very simple. So include only if it's bigger than 2. It's very difficult to, and the result will be the list of before. It's very difficult to write it any shorter or more compactly than that. Yeah.
Are the friends after filter required in Kotlin?
No.
Okay, just like so.
Yeah, I wanted to emphasize here that this is still like a method call. But yeah, you can use like a trailing closure syntax, which is fine. A trailing closure. So if the last parameter to a method is a closure, you can omit the parentheses. So I could just like erase the parentheses here and it still works. It's fine. But yeah, this is just to emphasize that we're still actually calling a method and the parameter is a function in the method. Here's another thing that I have written several times over in Java. Figuring out if anything in a list matches something I'm looking for. In this case, we're saying, do any of the elements in the list match the condition they are less than 0? And in this case, the answer is false. And in Kotlin, we have an any operator to apply that check for us. Are any of these things less than 0? I'm going to speed up a little bit because, again, these are all quite similar. The reverse of that is, what if I want to check that all of these things match a condition? In this case, I'm asking, do all of these things match are greater than 0? And the answer is yes. And I have an all operator that will do that for me. And then this is the final example, I think. So taking a list and then joining them into a string in some way. This one gets really ugly. You sort of start out with your mutable string, and then you run through your list, and you have to do this by index now instead of by for each, because you need to know when you're at the end of the list to not put the last separator on there. Okay? So what I want to do is separate this list by a semicolon, but I don't want there to be a trailing semicolon space on the end. So if I'm at the last index, again, I have to make sure I'm not off by 1 erroring here. If I'm not at the last index, then I put the separator in. If I'm at the last index, then I don't. Hooray, Kotlin. I can just call join to string, and I can provide the separator, and it's smart enough to like do that for me. There's no like mutable string hanging around that I have to keep track of. There's no like trailing semicolon left on the end. It's all just what I want. Right? It's just kind of fun. So I think this is also the first time where I've explicitly shown that you can, if this is optional in Kotlin, you can name a parameter when you pass it to a method. And this can be useful if you have several parameters of similar types. In this case, I'm doing it as a lead into the next section, which is default parameter values. So this is the example that we saw on the previous slide. I have this list, and I called join to string, and I passed it one argument, which was specified that the separator should be the semicolon. Here's the actual declaration of that join to string method. So it actually takes 6 different parameters. And you can see that, unlike in Java, what we've been able to do here is specify a default value for each of these. So when I invoked the method, I only had to provide the one that I wanted to customize. In this case, I wanted to say, okay, instead of using the default separator, which is a comma, I prefer to use this semicolon separator. But everything else is fine. You can leave it as it is. So there was no prefix applied. There was no postfix. I didn't truncate because I didn't set a limit. So if I wanted to do something different, if I wanted to say, okay, actually I'm okay with the comma, but I'd like to put parentheses around this, then I could specify just the prefix and just the postfix and not specify the separator and obtain a tuple-like representation. So how many methods would it take to obtain the same functionality in Java, do you think? Okay. So the answer is 64, right? Because it's like you have to have every combination of all these types. But you're actually also going to run into an additional problem, which is 4 of these parameters have the same type. They're of type character sequence. And Java's methods need to be unique in terms of their name and signature, like types of the parameters. So some combinations are going to look identical, so you're going to have like a join to string 2, join to string 3, where you take two character sequences, but they're two different character sequences. It's like, you'd never want to try it. You'd never want to try it. This is one method replacing all of that hard work. Love it. It's really nice. And again, you can do this in your own methods. You can define your own defaults. I find it really nice for dependency injection. Inject something by default. Don't have to declare it everywhere. And then in tests, inject a custom version. Yes. Yes. It's not there. And then think about the code you have to write to generate default values in that option. So you probably end up writing a builder. That's something that we haven't specified. I didn't specify as an example here, but you can use this in constructors as well. So rather than having a builder, you can just specify your default values here and then customize it build time as you wish. No more builders. Yeah, and in Java, that's a separate file, probably. Oh, yeah. It's just a lot of hand wringing to obtain this kind of functionality. Yeah. Say that again, sir. Yeah. It would probably infer that it was the first one if you didn't name anything. As soon as you name something, you have to name everything. Yeah, worst case, yeah, that would be what you have to do. I think if you pass just unnamed parameters, then it will assume they are in the order if they match the signature. So you would, I think in this case, you'd be able to get away with just passing the value. No, you could pass it, but it would probably be interpreted as the separator. So yeah, I guess it's kind of a gotcha. But you should always be looking at the method signatures of methods. No sympathy. Okay, so the next thing is data classes. This is how you declare a data class. This might be the first time I'm showing you a class declaration as well. You declare a regular class by just saying class name. You just add the word data to make it a data class. And then what we're doing here is we're passing in the pieces of data that this class is going to wrap and represent. So in this case, this represents a complex number. And we're passing in real and imaginary parts. So this is how I would construct a real number, complex number, sorry. Property access syntax. I'm not going to say too much about this, but you don't have to write getters and setters and all that nonsense like you would do for a Java class, a Java Pojo. One of the things that's nice about declaring a data class is that it automatically gives you a decent toString. So rather than just printing out like the actual reference in memory of this thing, it prints a usable representation straight away. I didn't have to write my own toString. It also has its own built-in equality check, just based on comparing the values of the data that it wraps. I don't have to write my own equals to avoid an object identity check. Again, I wrote the Java 7 version of this class with a toString and an equals and getters and setters. 55 lines. This is the only declaration you need to write a data class. You don't even need like a class body. That's enough if that's all you're trying to wrap. That's why we don't have destructive tuples, because this is so easy. Pretty nice. So the normal class in Kotlin wouldn't have a generated custom toString, wouldn't have a generated custom equals. One thing I haven't shown here, but there's also a copy method which allows you to do like a copy and modify and return a new instance. So it's like a mutability helper as well. So it's just if you look at the generated class for this, it's way more code than you get by just writing a normal class. Normal class would delegate to the object toString, the object equals.
Why not just make that
That's an excellent question. It's something I've thought about a little bit, and I haven't done enough production work to have a good sense as to what the downside might be. I guess you could argue the downsides would be unnecessary methods. Yeah, this is Android.
basically, if I have a representative model, it's super useful for that because as you wrote here, they're both files, so they can't be reassigned. They're saying, I've started my model with this value, I'm expecting it to be holding that value. And then those comparison checks that we were discussing, they're really easy to see. If I've got, say, a new spot by that model, and that's loaded in new parameters for me, I can compare to see if it's the same one or not without having to write that.
It sounds a bit trite, but I would say that my data classes are used to represent data. So like, I wouldn't make an activity a data class, like even though it might be useful to have a toString, it kind of is, there you're kind of abusing the semantic meaning of the word data a little bit. So yeah, typically it's just when I want to wrap some values and maybe expose some computed properties, but not to a whole lot else. So there is a Kotlin file can contain multiple top-level declarations. So you could have a bunch of data classes all in one file. If you're only using it in a single context, you could just add it to that file along with another class. Kotlin's pretty free. No, I think kind of like similar issue with extensions. There is no canonical way yet of doing that, so it's kind of up to you to figure out what your packaging strategy is going to be. Yeah.
So the equals.
Yes.
There. How does Kotlin avoid the gotcha of, are these two things like primitively equal, or are they referencing?
So it doesn't avoid it so much as it just matches what Java would do in that sense. So one nicety is that in Java, if you use the equals equals, you're doing an object comparison, and you have to call dot equals to invoke the method version. In Kotlin, this invokes the method version, and equals 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 invokes the object comparison, the reference comparison. Yeah. So again, it's a little bit of streamlining of the functionality. It's a little confusing that this equals equals is not the same as the Java equals equals, but you've got the same breakdown between object reference equality and
How about this constraint is a non-functional type or director, like custom type or non-native class type?
I don't know that Kotlin primitives are kind of funny. I don't think they're as primitive.
Well, there are no.
Right.
Everything's in class.
Yeah.
Well, some of them will compile down to primitive equivalents.
Yeah.
But that's all under the hood. So yeah, you could use like a Kotlin int as a generic parameter if that's what you're asking.
Yeah. So now the example shows you use that one as a field over there. Can you add a data class for example?
Oh yeah. Yeah.
And with the generate this toString is actual real reality.
That's a very good question. I would guess it would just forward onto whatever implementation is there, but if you passed a non-data class in there, I have no idea. You probably have like your data class accidentally wrapping reference equality. But yeah, I don't know if there's any check to prevent that. That's a good question. Yeah.
That might be something we'll get to, how we can look at Kotlin bytecode and Kotlin code a little bit later, so you can investigate yourself.
Yeah, it's really easy to like dive into what Kotlin has actually done. Yes, Jeff. Yes. Yes, I believe so. Yeah, correct. I don't know that it buys you a lot because you couldn't equally make it private to the file at the top level, but it's doable. I think you could also have data class inheritance now, which wasn't a thing at first. Yeah, you got a hash code, as you mentioned. It's weird, boring, but yeah.
Hash codes are awesome.
Boring. This is about fun, Brian. Hash codes aren't fun. They're an implementation detail. Okay, this is the last thing I think I have to say before I hand over to Matt. Sealed classes. I unreasonably love sealed classes. They're probably not as exciting as I think they are. They're like, there's an interesting sort of iOS, Android, or Java, Swift, Kotlin comparison here. So Java has enums. They're kind of cool, but they're all like compile time declared, right? So you say north, south, east, west are my directions. You can't like modify those enums or create instances associated with values. In Swift, you have enums with associated values, which is sort of a case where you can say, these are the types of my enum, and I would like to be able to associate instance data with them. It's kind of super useful. Sealed classes go beyond even Swift enums. I'll just show you. It's so good. So what happens is, so I take this, I declare the sealed class payment method, and what it allows me to do is basically I can control subclasses of this thing, and I can limit them. And what is happening here is I'm saying, okay, there are two subclasses of payment method. This is my subclass in syntax, just another colon. I'm saying there's cache, which is a subclass of payment method, and there is card, which is also a subclass, but it can take a number which represents the, a string which represents the card number. And then if I was doing something like, let's imagine I'm building an API and I need to build part of the URL based on which payment method I'm using. I can do, the when statement is equivalent to the Java switch, and it will allow me to sort of iterate through the cases. It's a little bit more powerful, but that's one of the things I'm not going to say too much more about. But I can check, if this is a cache payment method, then just use the /cache endpoint. And if this is a card payment method, then use /card/ whatever the number is. I don't know if this makes any sense as an API, but it's a good example. So the key thing here is there's no default branch needed. If this was Java and I was using, an enum, first of all, I'd probably have to declare like a number on cache as well, and it would just be null, and it would make no sense whatsoever. And you'd have to bake all that knowledge into your head, like out of band. Here, like there is no concept of the cache having a number. It doesn't make any sense. And so this is one of those examples where Kotlin allows me to express in code the ideas that are in my head way better than Java does. Some freebies here that I'll touch on very briefly, unrelated to the sealed class stuff, just a few last little bits of fun. The when statement, unlike switch statements and if statements in Java, is an expression, so I can say return when, and then just whatever value I evaluate to in the when statement gets returned. No need to repeat that return in every single branch. The other thing that I'm showing here is implicit casting, smart casting. So in this check where I've checked, is the payment method a card? I don't have to then cast it back to a card to access the number. It already knows it's a card, so it's just like, yeah, you can have the number, that's cool. That's fun. And then finally, string interpolation. If I want to put bits of logic inside strings, I can do that. I don't have to like use plus signs, plus. Too many pluses. That's fun. That was fun? That was fun! Alright. Woo! You want to come stand over here, Matt? I want to press something.
Just like the Great British Bake Off, one person, Nell or Sue, has the fun job. I have the less fun job, but the profitable job. Discussing profit. Why should we be bringing in Kotlin to our projects? Eyes and foods. So, we say profit. What does that even mean for us? Well, one of Kotlin's biggest features is it has null safety built into its type system and to some of the operators around it. It's 100% interoperable with Java, so we don't have to ditch the Java code we've already written for our projects and libraries. In fact, we can directly reference it, and vice versa. Our Java code can reference Kotlin. Better mutability support. There are, as we already discussed with val and var, pieces that say whether something is read-only or writable from the beginning. But we'll also talk about some concepts of types within Kotlin and its standard libraries that allow us to declare what's mutable, what's not, and what we can do with it. Boilerplate reduction, we've already seen from the examples before about how much more concise we can get our code, but I'll give a couple more examples about that. And Effective Java, it's a book we have in our upstairs library about what are some good Java practices. Folks at JetBrains took Java and wanted to make a language that was concise and modern, but they took a lot of the principles of that and baked it right into the language. So you can think of it sort of as a Swifty language, but I think it's more like a concise, effective Java as a language. Yeah.
You have to at least separate your code into modules, right? You can't have a single module with Java and Kotlin.
I've been able to do that, but it requires that I specifically say Java dot whatever or Kotlin dot whatever. It's usually best in your project if you separate your source into Kotlin and Java packages.
Right. The complex is the same file.
Right.
That's the problem with that argument. So you can't mix them in the same file. Not in the same file. You can have them in the same source. Okay, so they don't have to be separate modules, right?
They don't have to be, no. But you do need to reference that this is a Java dot packaging dot something. I was even playing with that as we were coming up with some of the code for this. So if we talk about profits, we have both revenues and costs. And what we want to convince you of is that the revenues outweigh the costs for wanting to bring this into our projects. First thing I want to talk about is null safety.
I don't know how you pronounce this last name.
So he was involved with some of the creation of Java as a language, and he says, I call it a billion-dollar mistake. It was the invention of the null reference in 1965. And unfortunately, we're all needing to catch, if we work with JVM languages, we're catching null, we're handling it, we're checking it. But this goes even further by our friend Jake Wharton by saying the trillion-dollar mistake, assuming the billion-dollar mistake of null is its existence and not the absence of support in it in its type system. So while Kotlin doesn't eliminate null, and in fact you can have as much fun with null as you want, there are features of it that allow you to handle it better and practices for it baked into the language that make you want to use explicitly non-null types within your code. So this is an example. Let's say that we have an existing set of Java classes. One, just a generic container wrapper, in case you like holding things within things. It takes a container. And then there's a container, and it takes a string. They're both set up by passing in an argument, and there's no specification of whether those things can be null or not. By default, any reference of an object in Java can be null. So if someone called into those arguments and passed in null for both, well, we would need to be handling that. So if we were to take whatever string was inside that container wrapper and do something with it, we first want to check, is that container wrapper that I'm getting back from my API null? Okay, it's not. Cool. Let's check out the container. Is that null? It's not? All right. Let's check out the container.string. Is that null? If it's not, let me go in and say system out print line. There are this many containers, or this many characters contained within. And then you do that dereferencing, you get to length, and it should be safe. If we were to use that existing set of Java classes, Kotlin makes it a lot easier for us to decide when we want to do something with what could be null. So we could get that container wrapper. Notice also the implicit type. It knows it's a container wrapper set to that ball. And then notice the question mark there. If you're already familiar with Swift syntax, it might seem familiar to you. Container wrapper, question, container, string, not sure. Aha, but if we get here .length, I can then call let to apply this function to run. So at this point, we've got the length. I'm using that length. That's what's being referred to as it there, running inside that block of code within let. So we print just that length. And if any one of those things in that chain from container wrapper to container to string is null, it will just be null, and it won't run that let block. Sort of like a guard statement in Swift. Yeah, so the typing, the type system either explicitly declares a bang or a question mark to say whether it is always non-null or maybe not. Good question. So in this case, I just took the length, but I could have also put the let on the optional string, and at that point I would need the braces to say take it and get its length.
Oh, the braces are just for a string.
Right. So you could think of it like or string or anything that could be like a int or a double or could be represented as a string. In this case, though, I've already got the length from it, but if you're going to do any more operations, let's just say dot operations on the thing passed in, that's when you want to be using curly braces to say it dot something. Otherwise, if you have exactly what you need, you can just put it right after the dollar sign. Yep. Yep, yep. So let basically says run this quote, run this function with the scope of what's happening. So in this case, it's on length, and that's why we can reference it as the parameter passed into the function. But it only runs if the thing that's going to happen is not null. It's not a null receiver type. So in this case, it's not, because it passed through all that, and it allows us to print that line with whatever the string length was. Yeah.
With the small cost.
Mm-hmm.
How to speak about say 15 now. Is it backslash?
That'd be my guess.
Yeah, I'm guessing. I'm not sure about that. Could be worth experimenting and seeing. Any other questions about that? Thanks for sticking around a little longer, too. Let's see. Another way that we could have represented that from the start with non-null types is to declare our classes in Kotlin, specifically saying that our data class container wrapper has something that can only be assigned once, a vol, and it's a container. By default, if you're not putting a question mark at the end of a class declaration, it means it should not be null. I can also say for my container, it takes a val, a string, and it's also non-null because there is no optional question mark declared in the type. What that allows us to do is then when I want to print that line, I could flat out avoid the let and any of the optional dereferencing and just say print line, take the container wrapper, everything within it, and print out that length. That also addresses the question before. Now we're putting in those curly braces to say, take that thing that I've got and start applying operations on it. Some other ways to deal with nulls. So for instance, let's say we have this val L that happens to be an int. We are not sure if this thing B, which is optional, it could be null, has a length or not. But what we can do to handle that is to say if it's not null, return B.length, and that return is implicit because if is actually an expression within Kotlin. So by saying that we're assigning it, this expression runs, and it could end up being B.length. But if it happens to be null on the else side of it, it returns -1, and it sets that for our value. We can even condense that a little further with a fun little trick called the Elvis operator, which it sort of looks like a curly piece of hair and some eyes turned sideways. By saying, let's set L to be B, optional dereference on length. If that is null, then I want you to do -1. And if it isn't, return whatever B.length is. So that's more shorthand on that. If you feel like having even more fun and you love NPEs, you can use what I call the bang bang operator, but it's never fully called that in Kotlin docs. But you could say, I don't care what it is, give me the length of B, and if you say bang bang length could be a null pointer exception if B is actually null.
Is a single bang mean anything?
Single bang will be used for expressing some types in Java that could be nullable. I'll show that in just a sec. But bang bang is how you would absolutely null dereference and could get an NPE out of it.
That's like Jeff Ray saying, don't ever use this operator.
Yeah, you really...
This would be, if you see big explanations, get them out of here.
Yeah, exactly. Yeah, this should cause an alarm. Some other ways that you can handle null is by filtering them out. Again, this is a really handy standard library trick where if we have a nullable list, we have a list of int question mark, meaning that these ints could be null. I've said that it's a list of 1, 2, null, and 4, but then I could filter those out, and the return type should be a list of 1, 2, 4. This is a really big part of why this language is fun and profitable, is to be able to reference Java code you've already written and have it reference back. You can call Java from Kotlin. There are equivalent types. So some of the Java primitives get their own Kotlin representation. Some of the more complicated types in Java also get their Kotlin type. Notice there, the bang is how Kotlin would represent a equivalent Java type that could be nullable. Then for byte, short, integer, long, anything like that, we've got the optional type set up there to say it might be fine. Actually, I think I misspoke there. If it has the bang, it means it's non-optional and it must be set as something that is non-null. If it is instead set as something with a question mark, it means you must check its reference. So if something passes a return value from Java and calling it from Kotlin, and its equivalent type is question mark, that's when you must be checking its optional characteristics. So for instance, I could take a non-null related to strings. I can add that, check its size, get the item out of that list. The thing about that, though, is ArrayList is set up as Java. The string that I used here was the Kotlin representation, or the Java representation of string. So if in that item that I got from the previous step, I'm trying to get the substring, there may have actually been a null item within there. And at that point, even though Kotlin will let you call on that code, that's where you've got it. That's a gotcha you've got to keep in mind, is that it may throw an exception if the item is actually null. You can also call Kotlin from Java. So for instance, things like our vars, if I say first name is Matt, there is an equivalent Java representation. So if you compare that back to Java 7, you declare a first name. It has an equivalent set of getters and setters. And then by calling that equal sign, by saying it equals Matt, it's the same thing as calling on that setter and putting in Matt as a argument to that. If you have something set up in your Kotlin code, say for instance a package level function that you really like, it does stuff without depending on the object that holds it or the class that holds it, you can reference that from Java. In this case, I just created a new foo, but then I can take the package demo, call in the Kotlin file there, which is example KT. That's how that's represented in Java if the Kotlin file is example.kt. And then I can call bar on that. So it's taking the package, the class, and then calling the function within that equivalent file. One fun thing I learned is that there are some other annotations that you can use to set up your Kotlin code to be more usable within Java. So for instance, you can use these annotations for saying what your file name is, and you can split it across multiple files. So let's say I have in my same package foo and bar. I've named it utils, and then in Java I can say package demo, call on utils, and get that foo or bar method. I can also set up my properties within my Kotlin classes to be available as a field in Java. So properties are a little different from fields in Java because they have automatically set for them getter and setter methods. But by saying that it is a set val ID JVM field, it allows us to access that within our Java code. So we could say when I get that ID, return from that class C the field ID. We can also create a fun addition to our Kotlin class called companion objects, which are essentially things that you can call on your Kotlin class statically, as we would have expected from Java. So if we wanted to say call class.bar, we could do that within Kotlin. We can use the JVM static annotation to allow us to call it the same way within Java. So for instance, in this case, we declared a JVM static and say c.foo, c.bar is not a static method. However, you could also call into the companion within that class, which will be treated statically within Java, and you can say companion.foo, companion.bar. Ability support. For instance, if I create a list of 1, 2, 3, 4 in my items, as we saw, we have some nice standard library methods to say what's the first, what's the last. Let's filter out whatever doesn't apply to that function. I could create a rewritable list that's a mutable list of things that allows us to add or subtract values from it. In that case, I could filter that there are no nulls in there. In this case, it just returns the same thing. I could also use that and say, require that none of them are greater than 6, and in this case, it returns that. If we instead had a mutable list of 1, 2, 3, null, require not nulls would be able to change the value of it because we've set it up to be a mutable list. Another example of that is if we have, say, members that are a mutable list of 1, 2, 3, and we created a read-only version of it. This is a gotcha to keep in mind because even though we said that that's a list and not a mutable list of integers, I can print what numbers is. It's 1, 2, 3. I can add to numbers, and then I can read what read-only view is supposed to be. I would have expected that to be non-assigned again, but because its reference is a mutable list, we've kind of lost some of the security that we get of having an immutable list. So by saying print line read-only view, it's still referencing the mutable one, which has been changed underneath. So if you really,
well, if you were to say like read-only view dot add, that work as well referencing the mutable list, or would that not?
This would be the list of guys.
Yeah. Yeah. Now, if something happened to change underneath, that's something to keep in mind. So, as much as possible, you want to be using the the immutable version of it. This is just to show it is possible to change from underneath what we thought was not changeable. However, because now we're saying read-only view clear, you can't do that because that's the interface exposed, and Kotlin will not allow you to do that. Boilerplate reduction, we've seen plenty of this already in the presentation, so I'm going to kind of step through this pretty quickly. You can set your val L to be 1L plus 3. In this case, it's interpreted as a long, and it's inferred that L is indeed a long. There's no new keyword in Kotlin. That's a big change from Java. Instead, constructors are treated somewhat like functions. You can have multiple of them. Most of the time, the one right at the top of the class is treated as the primary constructor. And there are nice shorthands for how you can condense what that looks like. You can also create explicit constructor functions. However, because it is mostly an invocation with the same name as the class, Kotlin's smart enough to know, okay, you want a new one of those. I'll give you that. And as we noticed through the whole presentation, no lag, or it's not, no semicolons required at the end of it. And because JetBrains created the IDE around it, it will warn you if you put a semicolon saying, you don't really need that there. It'll flag as a yellow line in your IDE.
What? You actually like write more than one single line separated from the semicolon.
He really wants it.
Yeah. So if you're really looking for the most condensed code, you could probably do something like that. Now here's some costs associated with Kotlin. Hopefully we've sold enough so far that these do not outweigh what we've already discussed. There is some performance overhead to be considered. When you look at Gradle build times for Kotlin, if you want to see more on the research of this, you can go to this blog post linked within here. But you can build without using any Gradle daemon, a fresh build every time. Kotlin does build slower. You can compare that, though, that if you're running consecutive builds using the Gradle daemon, they do taper off. The first one slower significantly, but they're not that much different. If you end up using some additional arguments, like saying incremental builds, use the Gradle daemon, then you see some nice performance benefits from Kotlin. So it's something to keep in mind as, say, you're setting up running it builds on your machine, or although you can't, say, have the daemon running within a Jenkins job, you could turn on, you could potentially look into some of the other arguments that are built into later versions of Gradle for optimizing this. So I'm going to also talk about some memory overhead associated with the abstractions that we get as part of Kotlin and its standard library. You can also read more about this here. For functions, for instance, if I'm, say, filtering a set of ints, in this case, I'm saying it must be greater than 0, and for each one of them, add on. That sum is outside the closure, and in this case, it's called a capturing lambda because it gathers something from outside the function body. It's not a pure function as we would have from something like Haskell or declaring a function that only works on its inputs and returns an output. If this happens, the way that Kotlin compiles down is to a function object. And that means that every time, say, this lambda is run, and in particular, if it's passed in as an argument to a higher order function, because functions are treated as first-class citizens within Kotlin, therefore, they can be passed around as arguments. If this, for instance, was passed in and it had a reference to some, Kotlin would turn that into a new function instance every time. So then it creates a new one. Every time it runs that lambda, it then runs the garbage collector on it, which increases some garbage collector pressure within your code. It's interesting because unlike Java, which requires, say, putting in a final variable for running a callback so that this kind of thing doesn't happen, the designers of JetBrains decided they wanted variables to be captured that are captured in the closure that they could be modified. In this case, sum is modified, and it's from outside the function body. Companion objects, although I love them, I think they make calling functions within your Kotlin classes way easier. If you just declare a simple companion object, I could set up, say, a tag. If I'm doing a debug statement, I could say, what's the tag? How am I doing this? So it could be, for instance, the class name. Looks pretty innocent until you see the equivalent Java code, which in this case, if you're trying to get to what is set as tag, and you were going to call that hello world method on your class, that would require jumping into the companion object to call that access get tag, which calls on the string get tag, which then refers back to the class, a static method with that, which then refers to the string set within the class, what is tag. So although it seems pretty innocuous, it has a little bit of boilerplate Java underneath it that has some memory overhead. It increases the number of method counts associated with your app, and if you're already running pretty high on those, it's something to keep in mind. You can also learn more yourself. This is a fun process. You can make sure you have the Kotlin plugin installed in either Android Studio or IntelliJ. Go to Tools, Kotlin, Show, Kotlin bytecode. If you don't understand bytecode, it'll be there, but it'll also have a decompile button at the top from which you can look at what would be the equivalent Java class. You can learn what things might be more performant and what things are not. Especially related to creating new function instances or some of the syntactic sugar we get around extensions or companion objects, could be helpful to see what is the additional method count, what's the additional memory overhead related to it. Some setup required. If you're using the stable version of Android Studio, you do need to install the Kotlin plugin. From there, it will require some prompts and making sure that the Kotlin version you're using with the Gradle file matches the installed version for IntelliJ or for Android Studio. IntelliJ latest version seems to have the plugin automatically installed, but these take not very long to set up. It's just something to keep in mind. It's not out of the box, but it will be as of Android Studio 3.0. And of course, we love and we hate the JVM for the things it can do. It runs everywhere, but it has its intrinsic slowness. It is a virtual machine. It's not the same as running compiled code. The developers at JetBrains came up with an idea for Kotlin native, though, which allows it to run on actual CPUs itself as an executable. This is still in very early stages. I think it's on version 0.2 for Kotlin native, so not released to the public yet. But it's something to keep in mind that as the more we learn this language and the more it's supported, it will be able to run on devices such as your computer or terminal or potentially even your iPhone. So let's wrap things up. There are good resources for learning. The Collins teach you a lot of the things that we've covered today, but in a very TDD format. You can download a package to your IntelliJ or Android Studio and make tests pass while learning. You can look at the Kotlin in Action book. There's an exorcism track for the language, just like many of the other modern and popular languages. And we have a Slack channel within Detroit Labs, #Kotlin. There's also a resource community for that. There is a Slack channel for Kotlin. You can go to kotlinlang.slack.com. Weekly Kotlin newsletter, Kotlin Weekly. Talking Kotlin podcast. I'm not sure what release intervals they have, but I think they're somewhat regular. And upcoming this year is Kotlin Conf in San Francisco, where the designers of the language will be keynoting, and other prominent Android and Java developers will be there to talk more about what they're doing with the language, potentially also talking about support, libraries, concerns that we've talked about here, ways of just knowing more about the language. So we've had plenty of questions throughout the course, and I think it's awesome that you've had so many questions, but we're happy to take any others at this time. Yeah, thank you so much for sticking around. I know we ran a little over.
So it's a double back.
Refer to it as YOLO, yeah. Cool, I'll keep that in mind.
There's still Java notions of an interface or
There are interfaces and abstract classes in Kotlin. What's interesting about them, we didn't cover it today, is that interfaces can have functionality within them, just as if you were having Java 8. And abstract classes can also have certain things defined, certain function behavior defined within them. I've used that in some of my code for interfaces that I want to represent a certain type of behavior, but have a default functionality, and let anything that specializes beyond that do whatever extra. I found that to be really useful. And there's plenty more information about that on the Kotlin docs.
So, Android kind of say that it's supporting what that really means. Because in the way able to run that Android with a light code called mobile extra market.
So I think I alluded to this a little bit earlier, but I think one of the things that promises is really just something about great stuff in the company. Another part is with the whole packaging of Kotlin support in Android Studio. So it's not the case that you have to go log in, set up things now. If you want checkbox in some of your projects, include Kotlin support. If you do that, it will apply the plugins, build your source directory. Kotlin was developed by JetBrains, and as part of this announcement, they also moved sort of oversight of the language away from JetBrains itself into a non-profit that has JetBrains input as well as Google input. They're also a little bit more involved now in the management direction of the language as well. But yeah, it's an all. I agree, it's not super clear what first-class support really means, given that it's all JVM 5.0.
Thank you very much.